Okay, so let's go over the homework on using all of the conversions. So now again, on these ones, you had to use some combination of all of these different ratios, right? On these ones, we're using one balanced equation, right? That's what it told you in the questions, was we're using that same balanced equation up there. So we're gonna start with letter A. Letter A says, what's the mass of water? So we need X, and mass is grams, we need grams of water. Is needed to react with 32.9 grams of Li3N, so 32.9 grams of this guy. Okay. Now, according to my advice on doing these, you always start with the one that's got a number and use the units to guide you. So here's my one that's got a number, and the unit is grams. So with grams, when we look over here, the only ones that I have that involve grams are this one and this one. Those are my only two, so it's not going to involve any of the other ones yet. Okay. So then we look at what are we trying to solve? We're trying to get to water and we're trying to get to grams. Hey, that's cool. So I could use this one because that goes grams of one thing to grams of another. I can do this in one step. Awesome. Right? Now, according to the cheat sheet, it says I need the molar mass for this guy. So I need the molar mass of this. So it's 3 times the mass of lithium is 7 plus 1 nitrogen times his mass is 14. And all of that times the big number on the front, which is 1. So multiply this out, this is 21 plus 14, so that's 35 grams of him. And then we do the water one, because that's my other one, so it's 2 times 1 for hydrogen, plus 1 times 16 for oxygen, all that times the big 3 out in front. So this is 18 times the 3, so that's 54 grams of him. So now what I'm going to do is set up my ratio of this to that. So 35 grams of Li3N needs to combine with 54 grams of H2O. So that came from the balanced equation. Now it says I don't have 35 grams, but I got 32.9. So 32.9 grams of Li3N gives me X grams of water. Now I just got to cross multiply and solve. 35 times X. 35 times X equals 54 times 32.9. Divide by 35 on both sides to get X by itself. So now I get X all by itself, and if you multiply this out, you're going to get 0.94, and that was grams of, oh, wait a minute, I'm sorry. I'm thinking of another problem. You cross multiply and solve this, you get 50.8 grams of water that's made. Remember, that's what they wanted. They wanted to know grams of water. That's what we got to, is grams of water. So the answer is 50.8 grams of water for this one. All right, so that was letter A. Sweet, this one was only one step. That's awesome. All right, love that. All right, so let's go to letter B. So I'll erase this. I'm going to keep these 2 molar masses on this because we're going to use the same equation for all 3 of them. And the molar masses are not going to change. Those pieces stay the same. That's also why I did them in black, because they're part of our recipe. All right, so we go to the second one. The second one says, how many molecules of NH3? So we need X molecules of this guy will come from the 32.9 grams of this guy. All right, so now again, we start with the one that's got a number. That's this one, there's my number. Look at the units, which is grams. So I can do this equation, or I can do this one, because those are my 2 that got grams. Now look at what I'm trying to find out. I'm trying to find molecules. Neither one of these gets me from grams to molecules. Neither one. So I got to do one of the 2. Right? I would probably do this one and turn this into moles. Once I get this into moles, then I can jump up here and go moles of this to moles of that. Right? So we're going to do this. We got to do molar mass of Li3N. So I got 35 grams of Li3N per the number that's out in front, which is 1 mole of Li3N. So that came from the balanced equation. I don't have 35, I got 32.9 grams of Li3N. Gives me X moles of Li3N. Cross multiply and solve. 35 times X equals 32.9 times 1. Divide by 35, divide by 35. And X ends up equaling 0.94 moles of Li3N. So I now know that this equals 0.94 moles. So I don't need the 32.9 anymore. All right, now I know that this is that many moles, just a little shy of 1. So now I know that that's moles. Now I can go over to this and go, okay, well, which one can I use? Oh my goodness, this one's got moles, that one's got moles, that one's got moles, that one's got moles. But what I'm trying to do is get from here over to there. So with that, I'm trying to get from one to another. That means I'm down to these two. Well, which one has moles? The very top one. So let's do that one. So according to that one on the cheat sheet, I got to use my moles from the balanced equation. So I got 1 mole of Li3N will give me 1 mole of NH3. So that came from the balanced equation. And then it says, well, I don't have 1, I got 0.94 moles of Li3N. And I'm going to try and find X moles of NH3. Am I still on the screen? Yep. Okay. All right, cross multiply. Ooh, this is easy because it's a 1 to 1. So X times 1 equals 1 times 0.94. So it ends up being the same number. But we are now at moles of NH3. So we now know that this up here equals 0.94 moles. And you might look at this and go, man, why don't we do that? That was kind of a waste because all is the same number. But what if we were, instead of going to here, what if we were going to this guy? Well, if we were going to this guy, then it wouldn't have been 1 to 1 like this. It would have been 1 to 3. So it would have been 1 and 3. Oh, that would have changed the number. So you got to remember to do this step. This is the step a lot of people leave out because they kind of forget about it. But you got to at some point get from one substance to the other substance. All right, so now we're going to move over a little bit. All right, because now what we got to do is now we got to change moles into molecules. Well, we're changing units of one substance, so it's something on the bottom here. All right, which one on the bottom? It's the very bottom one. So we're going to use 6.02 times 10 to the 23rd over 1 mole of NH3. When we go, well, I don't have 1 mole of it. I've got 0.94 moles of NH3. And we're going to try and find X molecules of NH3. So cross multiply. So we got 1 times X equals 6.02 times 10 to the 23rd times 0.94. So we type in 6.02 exponent 23 times 0.93, and X is going to end up equaling, and look, it ends up becoming 5.66 times 10 to the 23rd, and that's molecules of NH3. Is that what they wanted? Yep, that's what they wanted, was molecules of NH3. Whew. Gosh, we got that one done. That one took 3 steps in order to solve. Okay. All right, well, time to move on to the last one. Okay, so last one, we're going to erase all this stuff because we are done with all that. And I'll erase the red stuff at the top, but I'm still going to keep the black stuff because that's still my recipe, and my recipe hasn't changed. I'm going to bring you back over to this side. Hold on. All right, so the last question says calculate the number of grams. All right, so we need X grams of this guy. It says X grams of Li3N. It must be added to an excess of water. So we got like an ocean full of water, so that doesn't matter. We just got gobs of it. And we're going to try and produce 15 liters of this guy. All right. So we always start with the one that's got a number. That's this one. And look at the units, which is liters. Well, the only thing over here that's got liters is the red one. So that's what we're going to start with. We're going to start with 22.4 liters of NH3 is 1 mole of NH3. Well, then we go, well, I don't have 22.4 liters, I got 15 liters of NH3. And that's going to be X moles of NH3. Cross multiply, 22.4 times X equals 1 times 15. Get X by itself. And X ends up equaling 0.67. And that's moles of NH3. So we now know that this equals 0.67 moles. So I don't need my 15 liters anymore. Now I know I got moles of this. So now that I have moles of this, I'm trying to get from there over to this guy. So really I'm trying to use one of these 2 top ones. So I got moles, so we probably use the top one up here. So we're going to set up a ratio of, let's see, I got 1 mole of NH3 needs to will get me from 1 mole of Li3N. And this is another 1-to-1 ratio. That's awesome. So I don't have 1 mole of this guy. I got 0.67 moles of NH3, X moles of Li3N. So it's 1-to-1 ratio, cross multiply, 1 times X equals 1 times 0.67. So that's the same number, so it's 0.67, but now it's moles of Li3N. So we know that this over here is 0.67 moles. Now again, I know it seems crazy to have done this, but what if it was a different one where it wasn't 1-to-1? What if it was 1-to-2, 1-to-3, 2-to-3, all right? You gotta make sure you do that step. All right, so now we gotta go moles to grams. Well, which one over here changes moles to grams? So it's this one. So I need that molar mass. I'm gonna move you over so we can get over to a part of the board that is empty. So I need the molar mass of Li3N, which happened to have been 35 grams of Li3N. We already calculated that way back when. And that's per the 1 mole of Li3N. Equals, I don't have 1 mole, I've got 0.67 moles of Li3N and X grams of Li3N. Cross multiply and solve. I'm going to turn you a little bit. There we go. So that's X times 1 equals 35 times 0.67. So X ends up equaling, let me look at my final answer, 23.5. And now it's grams of Li3N. Is that what they wanted? Yep. They wanted to find grams of Li3N, so that's what we just found out. So we just got to the end of this homework assignment. Goodness, this was another one that involved 3 steps. Remember, this is as bad as it's going to get in this chapter. All right, so it doesn't get any worse than this. All right, well, we'll see you next time. Have a great day.